Question 25. There are some red counters and some white counters in a bag. At the start, 7 of the counters are red, the rest of the counters are white. Alfie takes at random a counter from the bag. He does not put the counter back in the bag. Alfie then takes at random another counter from the bag. The probability that the first counter Alfie takes is white and the second counter Alfie takes is red is 21/80. Work out the number of white counters in the bag at the start. I'm going to define the white counters as being letter X. I know there are 7 red, so I don't need to give the red a variable, but I'm going to use the letter X to be the white counters. Now there's a couple ways of doing this, and I have decided to use a tree diagram to show all the possible outcomes. And let's just take a moment to look at this to make sure we understand it. When Alfie picks his first counter, he will either get a white or a red. I've let X stand for the white counters, and there are 7 red counters in the bag, so both fractions are going to be out of X plus 7, because that's how many counters there are in the bag. There are 7 red counters, so it's 7 out of X plus 7 for the probability of picking a red, and there are X white counters. Once he has made the first pick, that counter is not put back in, so there is 1 less counter in the bag each time. So instead of there being X plus 7 counters, there are now X plus 6, each of the 4 possibilities. If I picked a white the first time, and the number of white counters in the bag is X, there must be X minus 1 counters left the second time. And if I picked a white the first time, there are still 7 counters that are red left in the bag. If I picked a red counter the first time, there are still all of the white counters left, which I've called the letter X. And if I picked a red the first time, there are no longer 7, there are now 6. Take a moment to make sure you understand the tree diagram, because it's a common type of question and there's lots of different things they can ask once you've drawn it. This time they're saying the probability the first counter Alfie takes is white and the second counter is red. So we're looking at this pathway here that I'm highlighting. X over X plus 7 multiplied, because these probabilities are independent. This red counter didn't say, oh, it was a white counter picked before, I'm going to make myself more likely to be picked. These events are completely independent. So it's X over X plus 7 multiplied by 7 over X plus 6 equals 21/80. So there's a bit of fractional work to be done. So there's the problem we've got to solve. I start off by making a common factor on the bottom of the fraction by multiplying these two together, X plus 7 and X plus 6. Obviously X times 7 is 7X. Then I have multiplied all of the left hand side, or the 7X, by 80, and the right hand side by X squared plus 13X plus 42 to get rid of any fractions. I have tidied it up to set it equal to 0, because I know if I've got a quadratic I want to set it equal to 0 so that I can solve it. I've then spotted that 7 goes into 21, and that might be something that simplifies across the other coefficients in this equation, and it does, and I used my calculator to check that. The reason why I did that is because I'm expecting a whole number answer, because there are a set number of counters in the bag, so it possibly could factorize. So that's why I checked to see if something could simplify, because there could possibly be a whole number answer here, or there will be a whole number answer. This now wasn't too hard to factorize. It did take a little bit of playing around, and you could go straight to using the formula at this point, which may be quicker, but it does factorize into 3x minus 14 minus 9. If 3x minus 14 equals 0, you end up with x not being a whole number. Now that can't be the number of counters in a bag, because you can't have 4.67, or not in this case you can't. The other part of the equation said x minus 9 equals 0, so x must be 9, and there are in fact 9 counters in the bag. And we've made it to the end of the paper. If you have found this at all useful, please subscribe to this channel so that you will be able to find out as soon as we have completed other past exam papers.